free energy or over unity is a type of animal that stresses its host, the circuit that hosts it. By its very nature, it's stressful, but stressful of a different type than the brute force of voltage that we tend to want to throw at our loads to solve the problem of where do we get our energy from? Throw voltage at it. And this stress that I speak of an over-unity circuit, it becomes evident whenever there are simulation errors that say something other than, oh, you got over-unity to an infinite gain and it just exploded in your face. That's a stress of a kind, very short-lived. But there's another kind of stress that is not explosive and the circuit doesn't die, which would be stress-free. It's error messages that convey the implication that the simulator could not come to an answer. It could not resolve an answer. And the one I keep getting now, more often than not, I mean, the only one that I get that's not over unity explosion is the time step is too small for transient analysis. Now, in Paul Falstad's simulator, he would say convergent error. You know, he would just come out and tell you. These people are a little roundabout about everything, you know. Matrix is singular, you know. They don't just say nan-infinite matrix, which is what, you know, Paul Falstad says. So I had to learn the nomenclature of microcap software to be able to interpret what were they telling me? What does it mean? Just by trial and error and experience, I had to figure it out on my own, because they don't tell you in the help file. Not this kind of translation into common sense terminology. So what I read recently is that equivalent series resistance overheats a capacitor. It eats up the dielectrical material, just like, literally like paper aging in a book turns yellow and brittle and gets holes in it. Well, a lot of the dielectrical material of capacitors is paper alternating with layers of foil. And I guess that's one way to do it. And the paper it weathers and ages just like the pages in a book. And when you get holes in it, then you've got yourself a short. And it slowly degrades, and before you know it, the capacitor isn't good for anything because it's been stressed. Now, what can stress a capacitor? In my simulations, it's becoming evident that the simulator tells me, it actually tells me this, is when the frequency is too high. Capacitors, unless they're a small farad, you know, a small value of capacitance, you know, really, really small, that can handle a high frequency, once we start to raise the storage capability of a capacitor by raising its farads, it gets stressed much more readily under high frequency conditions. And I'm talking actually not high, but moderate, you know, like 20,000 cycles per second. It's been giving me error messages, yet if I lower the frequency, it's able to handle it, and then I can raise the farads. I have it raised now to 1e to the negative 5 on all 4 of my capacitors. Because when I do that, when I raise their farads, their capacitance, I tip the balance more in favor of current at the expense of voltage, which is good because at the moment I'm trying to do battle with the fact that the voltage dominates the current by a factor of something like 8 to 1. I've managed to reduce it. I started out, it was 16 to 1. But it's a very slow process of all various factors that I have to juggle. I have to juggle the frequency as a last resort. I turn to frequency as a last resort only. My first move in trying to increase amperage and lower voltage is to raise the capacitance. No, actually, it's to lower the equivalent series resistance of the capacitors. I have it set to 70, and the reason why I have it at all is to stabilize the circuit, because if I don't stabilize it, I get error messages. Transient analysis cannot be done because the time step is too small. But if I go the opposite extreme, I'll get, you know, matrix is singular problems. Now, putting in a resistor here was what I initially did. Now, I keep all my resistors as legacy of what their purpose they're supposed to serve, even though I've reduced them all to 1 ohm. because I think what happens is they act as a locator for the equivalent series resistance of other components, such as the coils nearby and all of the capacitors, to find a location to manifest their hidden potential. Because we normally don't think of equivalent series resistance of a capacitor. It's like tucked away and we think, it's not important. It is. If you put a resistor nearby, it'll manifest there. Now, I learned this principle when I was studying an aspect of Tesla's special generator according to William Lyne. When he quotes Tesla, and he's the only source that I know of, so bear with me, there's not a second source to verify. He quotes in chapter 18 of his book, Pentagon Aliens, that Tesla claimed that his special generator would increase its output by 1 horsepower if 200 pounds of iron were added to his device. Now, he didn't say how it was added, and Thomas Comerford Martin certainly doesn't help us because he doesn't know either. He was there at a demonstration of the Tesla special generator in 1893, among other electrical engineers. But according to William Lyne, you magnetically couple your large body of iron, let's say the hull of an elektro-U-Boat from Nazi Germany era, or a battleship, or a 4,000-pound Pierce arrow. You magnetically couple the iron of a large mass to the large coils of his special generator. You know, he has a set of large coils and a set of very small coils. But the coupling coefficient will manifest in the small coils as above unity when I undergo simulation. But in the real world, we won't. Well, maybe there is evidence of seeing a coupling coefficient in the small coils, but certainly there'll be evidence in the large coils because you will have magnetically coupled their iron core to a much larger iron mass outside the core, something that won't fit inside the core or inside the coil of those massive coils of Tesla's special generator, 50 miles of winding. They were pretty massive. Horseshoe-shaped cores, 2 of them, with the feet facing each other, and then the little H-coils vibrating, reciprocating in between the feet, an air gap in between the feet, a very small gap. 2 pairs each, so we had 4 H-coils and 2 M-coils. The M-coils were the massive voltage coils, and the H-coils were the teeny-weeny current coils, and that were reciprocating and moving while the M-coils were stationary. But the M-coils had the massive horseshoe core, the iron core that was bolted to the vessel of the elektro-U-Boat, the elektro-U-Boat, the U-boat the Germans used in Nazi during World War II. Anywho, so I learned that principle that if you do something to one component, it'll manifest at some other component. And it took me a year to figure that out, for it to dawn on me, because I was so confused, like, what? When I was seeing the simulation in front of my eyes, I knew what it was suggesting, and I couldn't accept it. It took me a year to accept it. So, if it takes you longer or less, hey, some of us are slow, to accept new ideas. Well, here, I keep the resistors. I originally had them at higher values, and this was the last one to go, my spark gap ballast. And I lowered it down to 1, but I keep it located there. I don't remove it because I've learned now that what I've done that works in conjunction with it, and I don't even test it to find out if it's true. It's just a belief, okay? It's Vinny's belief that the equivalent series resistance of all my 4 capacitors wants to manifest there at this location, which is where it needs to be because it has to affect these coils and the spark gap to make sure it fires, yada, yada. So I covered that ground. Now, the other thing I wanted to cover, stress. So by lowering the frequency is my last resort. So the first thing I do to try to up the amps and lower the volts is I lower the equivalent series resistance that I've already put into the capacitors, because it was the only way to stabilize this thing. As I tried, it was the only way to fine-tune, there we go. It was the only way to fine-tune the wattage output of coil number 1 and coil number 2, the transfer coils, which used to be the rotors, but now they're called transfer coils. The rotor now is over here on the transformer, along with the stator on the opposite side. So in order to, because I was having huge differences, 30,000 watts, no, was it that? What was it? I want to think. Yeah, I think it was 30,000 watts versus 8,000 watts. And of course, my target is 60. No, no, no. It couldn't have been 30,000. It must have been 300,000. Well, whatever it was more than what my target was, and my target was less than my target, and I couldn't go in between. Not until I shifted the burden of resistance away from this resistor and into the equivalent series resistance of my 4 capacitors was I able to fine-tune my wattage output. But in so doing, it was at the cost of amperage, and so my volts went up and my amps went down. So now that I have the wattage under control, now I have to bring the amps back under control and the volts. And so the first thing I do is I lower the equivalent series resistance of my capacitors. And then once in a while I try to lower their actual capacitance to see if I can get away with it. You know, no error messages. Now, as a consequence to lowering the equivalent series resistance of these capacitors, or lowering their farads for that matter, I have to lower, is it lower or raise? I think I have to raise the inductance of these two coils because the overall wattage goes down. Now, I've already adjusted, I've chosen the wire gauge for these coils and all my other coils, so that's set at 20 Aug for these coils and 10 Aug for all the others, the 4 other small coils. So that's set. So if I run out of choices, you know, if I start getting error messages in my pursuit of raising the amps and lowering the volts, and I have no choices left, you know, I've tried everything, then as a last resort I lower the frequency, because the frequency does not change the power output one iota. It puts off the stabilization of RMS and makes it take longer. So it's easy to erroneously think, if you're doing a time analysis, you know, within a set time, that when you lower the frequency, your output is less if you're looking at RMS. And you successfully create the wedges, the staccato-shaped wedges. And I erroneously concluded that my energy level went down, and thus frequency can act as a throttle or an accelerator pedal. Nope. I was wrong. I was mistaken. All the frequency does is it changes the stress level of the capacitors, basically. But I use it as a last resort only. So I've been lowering the frequency now to bring down my wattage because my wattage is huge. But meantime, every time, see, I'm learning how to make changes in the correct manner so that I don't lose the gain I make when I raise the amps and lower the volts. So the last reading I got, let's see what my calculator remembers. 8 point, what does that say? My poor eyesight. Whoopsie. I'm going to have to, now I'm going to have to edit this video. What does that say? 8.368995. So that's a lot of gain in lowering. See, that's the value of the volts versus the amps. So that's a lot of lowering action from 1618. There we go. Sorry about that. Well, I've got an X-rated desktop. What can I say? Most people would, you know, a nudist wouldn't call it X-rated. They would just say, whatever. David Carradine had a nude, topless, nude, you know, above-the-waist nude portrait of his mom hanging in the dining room. Well, his father, actually, the Carradine family, the mother of the clan, had a portrait of herself in the dining room, nude from the waist up. So, you know, families are different. We're all brought up differently. Expect different expectations. So that's what I wanted to tell you, is how I go about this balancing act, because you're going to have to know, if you go and build this thing, you're going to have to know these things, because there's no guarantee that microcap simulation is accurate to reality. it's true they charge you. It's the rate for paying for this thing begins at $4,500 and then goes to 5,000, and it might go higher depending on who you are. You know, are you a student? Are you an educator? Are you part of some company? But if you're paying cash out of pocket because you're just a hobbyist, you get to pay the full price, you know, and I don't like that, so I nothing I can do about it. Anywho, I don't think they charge a high price and get away with nonsense. So that's why I put my faith fully in the company and how well their software can deliver an accurate depiction of reality. It's not easy creating over Unity and microcap, but I've graduated out of Paul Falstad's simulator to the point that I recognize it's too easy in his simulator, at least the one that was available for download several years ago, 2017 when I downloaded it, and I keep to that one. I don't want, because I knew, I kind of had a hunch that, you know what, I bet he'll make corrections and make it harder for me to do what I do, so I better stick with the version I've got. And that's why I don't upgrade my microcap either. I keep all the, hey, it's not giving me any trouble, why should I change it? So, because, people can put policies. I've seen it happen. They put policies into their simulators to prevent hobbyists like myself from producing over Unity. Well, one way is to up the price. Duh. That's an easy way. So I wanted to clue you into all these little tricks or these things to point out and to focus on because it's really important. And now I see there's a mistake here. I gotta change this to 15. So anyway, I just thought you might want to know. And also the thing about stressing capacitors. And so as I lower the frequency, I'm able to get away with lowering its equivalent series resistance because the equivalent series resistance acts as a stabilizing force to the capacitor, as well as to the circuit in general. But it's at a cost of amps to the benefit of volts, and I don't want that. So, little by little, I'm making changes. And my hunch is when I've had a lot of self-doubt, let me tell you. Yet, my conscience doesn't permit me to exercise doubt for more than a millisecond because it's pretty strong on the notion that I will succeed and that this is a viable concept of a circuit to toy with. But right now my target is for an EV, for an electric vehicle. And my hunch is I'll be able to make a table model shortly afterwards because all my prior work in circuit development did not take into account the Ferranti effect, namely the Heaviside problem that he solved. And so now I think it's becoming a complete concept circuit. Something that was incomplete up till now. It was a Joseph Newman version, basically, which is incomplete. A Joseph Newman motor is incomplete. Even with his proprietary secret of the helium in a glass canister wrapped with an open coil, is still, despite its over Unity, is an incomplete consumer appliance development. It needs more development, and that's what I've been doing. I took my simulation of his motor. I spent several $100 for an 8th edition hard copy, hard copy, not a paperback. There were only the hard available on eBay or Amazon. So I got myself, it cost something like $400, and which was very hard on my limited income, but it paid off because I was able to have the data necessary to create the simulation and then solve it in a way that Newman was not being honest and forthright about. And that left me confused in a dazed state because I couldn't understand what was going on until I met up with Byron Brubaker, and then he informed me of his little proprietary secret. And then still it took me a year of sitting on it. So if some of these things like Tesla special generator, the coupling effect, and Joseph Newman, it takes me about a year for just to walk away from it before I can deal with it because emotionally I like to trust people, But I also like to trust normal logic, and so anything that's out of the ordinary, I have a hard time with it. Anywho, so I'm now able to develop this circuit, and I think given the Heaviside perspective of how to go about synthesizing electricity, you know, in his case, he was healing electricity that he didn't need to synthesize it, although he was. You know, he was. Because the magnetism was dissipating faster, the magnetic field surrounding the live cable was dissipating faster, much faster than the electric field, and he had to heal it by regenerating the magnetism along the way, along the length of the cable. And he did it so simply, too, just wrapping it with the insulated copper cable core with iron wire and insulate around that and create coax, the very first coax. But it solved the problem. So he was synthesizing magnetism, a magnetic field, rather than allowing it to merely dissipate, which is what it normally wants to do over long, lengthy coils or lines of wire, copper wire. So he was synthesizing. And that's what I was failed to do. I was synthesizing a lot of electrostatics and thinking that by balancing the amps with the volts, everything was happy. But it's not an appliance. It's not a motor. It has no speed. It has all torque and no speed. So the Joseph Newman device is an incomplete development because it has lots of torque and very little speed. And we want a motor that delivers both. And that's the Heaviside challenge. Can you deliver both? So that you get your telegraph signal come out clean and crisp at the opposite end after hundreds and hundreds and hundreds of miles with no boosting stations along the way. How do you do it? And that's essentially how I went about this current stage of development of this circuit concept, was to look at it from the Heaviside perspective. So I have to thank him and credit him, even though he was persecuted in the end of his life and died of starvation, because the children, the neighborhood children, stoned him every time he left his home. You know, well, the guy kind of stood out, painting his nails pink and removing all the furniture from his home and putting it out on the front lawn and bringing in boulders and rocks and sleeping on that instead. I mean, obviously the kids would persecute anybody who appeared to be very bizarre, but as a consequence to the Royal Society of London crucifying him because he solved the problem, the transatlantic cable problem. He solved it elegantly, simply, using pure mathematics and no belief in anybody's system of beliefs whatsoever. So I have to exercise a certain amount of beliefs because I'm clueless what I'm doing. But that's why I turned to the simulator to bring me back to reality. And then I turned to Eric Dollard to make up the difference. And Jim Murray and Paul Babcock, you know, all those great people, Peter Lindemann and Aaron Murakami. I turned and people on Dave Turian, on, you know, and nameless, anonymous other people on Energetic Forum. You know, I turned to all these people to bring me back to reality and help things along, to fill in the gaps. But actually, it's the simulator that brings me back to reality, because the simulator tests all these ideas, and I'm limited to what the simulator can simulate. So I can't simulate everything, unfortunately. So I can't investigate everything. But I'm limited to what the simulator can provide. But at the very least, I want it to provide reality at this point in my development, in my learning process. I don't need loosey-goose simulators to give me anything I ask for, you know. I want to be challenged. So I'm being challenged, and it's a lot of work. It's taking me a few days to work on this to get it to where I want it to be, around 67,000 watts, and a amperage to voltage ratio of 1.67 to 1. You know, that's my target. And then, of course, the Heaviside approach. So I have those three criteria now. I have to solve and satisfy all three of them in order to come up with a circuit that just might power an electric car, and if it can be scaled down again in this current modality, or the Heaviside modality, then it can satisfy the requirements of a small kitchen appliance. But we'll see. That's a little bit off in the future, maybe the near future. Maybe closer to the near future than I suspect, but who's to know?